I just wanted to talk just for just a brief moment about lipids. And what I want to cover basically is the chemistry of lipids and the different types of lipids and their structures, their chemistry, their functions, those types of things. So for lipids overall, one of the things that they're very, very important for is for stored energy. Now, lipids contain 9 kilocalories of energy per gram. This is going to be more than carbs. This is going to be more than proteins. So what this means is that lipids are going to be a much more favorable source of stored energy. They're going to be much more energy dense. Basically, you're going to get more bang for your buck. So you can store more energy per gram with lipids. So lipids are going to be very, very important for storing energy. And they can be stored. We store lipids in adipose tissue, and it can be stored unlimited in unlimited amounts in our body. So we can continue to make an unlimited amount of adipose cells and adipose tissue to store these lipids. So when you think of lipids, we're going to think of that stored energy. So they're going to be that much more energy dense. Source, so much more than carbohydrates and much more than proteins. When we think about lipids, especially with food, the ones we think most of are triglycerides. And what triglycerides are is they're composed of a glycerol molecule, and that glycerol molecule is going to have 3 fatty acids coming off of it. So the tri would be 3, the 3 fatty acids coming off of it. And what those fatty acids are is those are just hydrocarbon chains. They're chains of carbons with hydrogens coming off them. That's why I call them a hydrocarbon chain. So triglycerides are going to be a glycerol molecule with 3 fatty acids coming off them. Like I said, that's what we're going to be most familiar with. We talk about food. That's going to be what we're going to talk about with the body, storage in the body. These guys are going to be important for energy storage. They're also going to be important for insulation in our body. They can help keep us warm. They can help cushion us. They can help protect our organs. So these guys are going to be important for those types of things. Now, some terminology that goes along with your triglycerides and with that glycerol molecule as a whole. So instead of triglyceride, is a glycerol molecule with 3 fatty acids. If that glycerol has 2 fatty acids, it's going to be a diglyceride. So di would be 2. And if it has 1, it's going to be a monoglyceride. Mono would be 1. So that's where those terms come from. Another piece of terminology has to do with those fatty acid chains, those hydrocarbon chains. Remember, the triglyceride is going to be glycerol molecule with 3 fatty acid chains coming off of it. Now, depending on the arrangement of those carbon and hydrogen atoms in that fatty acid chain, that's going to depend on a couple other. That's how some other terminology is going to come into play. If those carbons are linked together with no double bonds, we're going to say that fatty acid is going to be saturated. It's going to be a saturated fatty acid. There's no double bonds. Just those carbons and hydrogens. The carbons are just all linked together in single bonds, and the hydrogens are going to be coming off that, and that's going to be a saturated fatty acid. These guys are typically going to be solid at room temperature. Those are going to be things like your animal fats. Now, if there are double bonds in that hydrocarbon chain, we're going to say that that's going to be an unsaturated fatty acid. So unsaturated, there are going to be double bonds present. If there's 1 double bond, that's how you're going to get your monounsaturated. Multiple double bonds, this can be your polyunsaturated. So you've heard about polyunsaturated fatty acids. Those are going to be your oils. So those are typically going to be liquid at room temperature. Those guys are going to be your oils. So that's how you get those differences in the terminology. I know sometimes people don't quite get a grip on that, but that's where that's coming from. So those differences in terminology. Now, that you have your triglycerides, which is a form of lipids. Also, 2 other groups of lipids that are important. So you have your triglycerides. You also have phospholipids. Phospholipids, these guys are important for a couple things. What they are is they're going to be a glycerol molecule. Again, they're going to have 2 fatty acids, and then for that third guy, they're going to have a phosphate molecule along with choline. So that's how they're going to differ from triglycerides. These guys are going to be important. These phospholipids are going to be important for a couple things. One thing is they make up the phospholipid bilayer in cells, the cellular membrane, the phospholipid membrane. And what that does is it regulates what comes in and out of the cell. So these guys are kind of the gatekeepers of cells. They're very, very important because you don't want just anything coming into a cell. You don't just want anything to leave a cell. So These guys are going to play a very, very important role in cell membranes. The other thing that phospholipids are really important for, and this is due to their chemistry, I said they have those two fatty acid chains, and they also have that third that differs. What this allows them to do is to be emulsifiers. What emulsifiers do is they let water and oil mix together. If you put a drop of oil in water, it's going to segregate itself away. What emulsifiers do is they let these guys mix together. They help them blend together, mix together, so we can use them in food. And they're also important in our body. We need them during digestion. So that's another important role for your phospholipids. And the other group of lipids are your sterols. In structure, sterols are very different from the other two. They're in a ring structure. And just by the name, you can probably guess cholesterol is a very, very important sterol. And cholesterol is very important in synthesis of hormones, synthesis of bile acids, and that's going to be important for digestion. And one thing to point out about cholesterol is it is only present in foods from an animal source. So you're only going to get your actual cholesterol from foods from animal origins or animal sources. So for our three big groups of lipids, we're going to have your triglycerides, you're going to have your phospholipids, and you're going to have your sterols. And again, these guys are not structurally identical to one another, but what they do have in common is that they are insoluble in water. So they don't dissolve in water. They're not soluble in water. And the other thing that they're going to have in common is they're composed of carbon, hydrogen, and oxygen. So all of your lipids are composed of carbon, hydrogen, and oxygen, and also all of your carbohydrates are composed of carbon, hydrogen, and oxygen. Your proteins, they're a little bit different. They're carbon, hydrogen, oxygen, and they're also going to have nitrogen thrown in, which we'll talk about when we discuss proteins. So again, your big main groups of lipids, we're going to have triglycerides, phospholipids, and also your sterols.